Thanks for tuning in for another episode of Math with Mullins. Today we're going to be looking at our lesson 11.6, volumes of pyramids. So we'll be able to find and use volume of pyramids. The first thing we want to know is how to find the volume of a pyramid, and we can do that by finding 1/3 area of the base times height. So just keep in mind that big B stands for area of the base. That just depends on what your base is, and make sure you can find the area of that, and then timesing it by the height of the pyramid, which is from the base all the way to the point at the top. So we're going to try a few of these. The first one's pretty easy because it's a square base, so we're doing 1/3 times area of the base, so 10 by 10, and then times 12, which is the height. When you divide all that by 3, you should get 400 cubic centimeters. Number 2 is a little bit different because we don't have the area of the base yet, but we know it's a regular hexagon. So when I try to find the area of a regular polygon, I'm taking 1/2 of the apothem times the number of sides times the side length. In order to find the apothem, I need to also talk about my central angle. So center angle is 360 divided by 6, which is 60, and then half of that, which would be 30. So I've got my 30 there. And I need my apothem just to figure out the rest of it, because I know my number of sides and I know my side length is 12. So in order for to get me to this point, this is the tangent ratio, opposite over adjacent. So I'm going to take tangent of 30 is equal to 6 over a, which is equal to a times tangent of 30 equals 6, or a can be found if I do 6 divided by tangent of 30. And that's going to give me roughly 10.39 for my apothem. So I'm going to plug that into my area of the base. So 1/2 times my apothem of 1/2 times 10.39 times my number of sides, 6, times my side length, 12. And I'm going to get 374.04. So now I can plug that into my formula for volume of pyramids. So 374.04 times 20, and then divide all of that by 3. I'm going to roughly get 2,493.6 cubic centimeters. Okay. Next one, originally Khafre's pyramid had a height about 144 and a volume about 2,810,800 cubic meters. Find the side length of the square base. So I'm going to take the volume at 2,218,800 and set that equal to, I don't know the area of the base, times the height. My height is 144, so I'm essentially going to divide this big number by 144. So 2,218,800 divided by 144. I'm getting 15,408.33. And then because this is a square base, what I could do is find the square root of this one, which is about 124.13 meters. Okay. Next up, find the height of the triangular pyramid. I know that the volume is 14, and I know I can find the area of the base by doing 4 times 3 divided by 2, since it's a triangle. I don't know my height, but then when I'm done, I have to divide everything by 3. So the first thing I'm going to do is multiply both sides by 3. So I'm going to get 42 is equal to, I'm going to go ahead and solve this. 4 times 3 is 12, divided by 2 is 6, so 6 times the height will give me a volume of 42, and if I divide both sides by 6, my height is equal to 7 feet. Alright, here's one that you can try, so if you want to go and pause the video here, you can. When you're ready to check it, click play. Alright, the volume of a square pyramid is 75 cubic meters, and the height is 9. So I would say 75 is equal to big B times 9. Divide both sides by 9. 75 divided by 9 is about 8.3 repeating. So then I would just find that, but I forgot to add in my 1/3. So that's going to create some issues. So times 9 and then divide by 3. So first thing I'm going to do is multiply by 3 on both sides. So 75 times 3 is 225 equals to area of the base times 9 height. Then divide by 9. So 25 is equal to area of the base. So the side length of the square base would be 5 meters. Find the height of the triangular pyramid. So my volume is 24. That is equal to 1/3 area of the base. That would be 6 times 3 divided by 2, and height is unknown. First thing I'm going to do is multiply everything by 3 on both sides. So 24 multiplied by 3, I'm going to get 72 is equal to 6 times 3 is 18. 18 divided by 2 is 9. And then divide both sides by 9. The height is 8. Okay. Volume A and pyramid B. Pyramid A and pyramid B are similar. Find the volume of pyramid B. Remember, you could do this by setting your scale factor. I'm going to go from B to A, which is 6 to 8, or 3/4. So the volume of B over the volume of A can be found by taking 3/4 and cubing it. So the volume of B, unknown, over the volume of A, 96, is equal to 27 over 64, and then it just becomes a proportion. I'm going to multiply 96 times 27. I'm going to get 2,592, and then divide that by 64. I'm going to get 40.5 as the volume of B. Okay. And then find the volume of the composite solid. We have a cube and a square pyramid. So we would start with our cube first, which would be 6 by 6 by 6, or 216 cubic meters. And then my pyramid, we have 1/3 and then 6 by 6 by 6. So area of the base is 6 by 6, height is 6 by 6. We're going to get 72 cubic meters. And add that together, we get 288 cubic meters. Okay. Last one you can try on your own. Why don't you pause the video here, try this one on your own, and when you're ready to check it, click play. All right, I'm going to start with my prism at the bottom. So my prism at the bottom is a triangular prism, so that's 8 times 4 divided by 2. And then times 5 is the height. I'm going to get 80 cubic feet. And then my pyramid, I have as, again, 8 times 4 divided by 2 times 3 as the height, but then I have to divide by 3 anyways, so really it's just 8 times 4 divided by 2, which I get 16 cubic feet. And then that total is 96 cubic feet for that composite solid. That'll conclude our video today on 11.6 volume of pyramids. Hopefully this gives you some good practice with that, and thanks for tuning in. We'll catch you next time. Have a great day.